Hello, my name is Allison Harvey, and this video is going to focus on summation, specifically focusing on the formulas that we can use as well as sigma notation. So starting out, summation is basically when we're adding everything together, and it is also often seen in this sigma notation where you have an n on the top, you have a starting point, you have some value here, and you're trying to find the total sum. So breaking this down, what is I? So I is our starting point, or often known as the lower limit of summation, and n is our stopping point, or the upper limit of summation. It can also be thought of as how many times we're adding something together, specifically if we have like a constant. That's just one way to think about it. We also have 4 formulas that we use or can use whenever we are solving summation problems. And the first one is when we have a constant. So if you are starting at 1 and you are ending at some value of n, some number n, and you have a constant, the sum is the constant times that ending point. If we are finding like the sum of I, and we have, so we're starting at 1 and we're ending at some nth number, that sum can be found using n times n plus 1 divided by 2. If we have I squared, you can find the sum using n times n plus 1 times 2n plus 1 divided by 6. And if we are dealing with I cubed, you can use the formula n squared times n plus 1 squared divided by 4. And I just left a little note over here that you might recognize that this formula for I cubed is the squared form of the formula for I. So moving on to some examples, because I think everything makes more sense whenever you get to really see it visually. So starting out with 2 examples that deal with a constant, I just put a reminder over here when you're solving to remember that whenever you're finding the sum of the constant using summation, you can use the formula of C times N. And I personally like to use the formula. You could write it out analytically. I like to use the formulas unless told to write it out. So the first problem, we are starting at 1 and the stopping point is 8. We have a constant of 7. So we already know that we have the formula. If you have a constant, you can use the formula C times N. So that's what I did. And I did 7 times 8, which is 56. Second problem, we are starting at 1 and our ending point, our nth term is 5, and we have a constant of 9. So I again use the formula C times N, which is 9 times 5, or 45. So the sum of this particular problem is 45. It's basically, for constants, it's like you're basically adding this constant number n times, which is why we use this formula, just so you understand the background behind it. Okay. Now moving on to 2 more examples that deal with I and a constant. So our first problem, we're starting at 1, our n term is 4, and we have 6i. So for this problem, I actually wrote it out so that you can kind of see it visually. I wrote it out and I did the formula. So 6i. So the first term would be 6 times 1, which is 6, then it would be 6 times 2, which is 12, plus 6 times 3, which is 18, plus 6 times 4, which is 24. So if you were to write it out analytically, that's how you would do it, going up a term for that I term each time. So it would go from 1 to 2 to 3 to 4, and that stopping point is 4. And when you add all these together, it is 60. Now, I'm going to show you how to do it with the formula as well. So same problem. Now I'm just going to use the formula that tells us that to find the sum of I, you can do n times n plus 1 divided by 2. We have a constant out here. You just multiply this term by the constant. So this is going to become 6 times 4 plus 1. I put 4 in here because 4 is our nth term, if you can see that translation right here. So this becomes, divided by 2, this becomes 24 times 5 divided by 2, which I can factor out of 2. This becomes 12 times 5, which is 60. So this is perfect because both my terms match. So you can write it out and you can do the formula to check yourself. Do whichever one feels more comfortable to you. I personally like doing the formula because I think that it takes out mathematical errors that might arise. So next problem, we have a starting point of 1, and our end term is 5, or our stopping point, our upper limit of summation is 5, and we have the term 7i minus 3. So I personally am going to break this apart into 2 different sums, and then I'm going to add them together at the end, or well, really subtract them, but anyway. So the first thing I'm going to do is pull out my constant term, because I'm going to be multiplying it by I. So this is going to be 7i minus 3. So using the formula that we know, which is that you can find I by using the formula n times n plus 1 divided by 2. I did that and I plugged in for n, which is 5, so that's 7 because I'm multiplying by my constant term. Can't forget about the constant. That's 7 times 5 plus 1 divided by 2 minus the constant, which is 5 times 3, so minus 15. This equals 35 times 6 divided by 2 minus 15, and then I factored out the 2, so this becomes 35 times 3 minus 15. 35 times 3 is 105, so 105 minus 15 is 90. And you could also write it out analytically to double check yourself. All right, last 2 problems are going to deal with I squared and I cubed. We just have a reminder up here that to find basically the total sum when you're dealing with I squared, you can use the formula n times n plus 1 times 2n plus 1 divided by 6. And for I cubed, you can use n squared times n plus 1 squared divided by 4. So first problem, starting at 1, I equals 1. We have a stopping point of 5, and we are dealing with I times I squared plus 4i. And the first thing I did is I actually distributed the I. So this became I cubed plus 4i squared, and then I separated the sums. So I have I cubed plus 4i squared, and I separated them. As you can see, don't ever drop your sigma notation. So the first thing I did is I used the formula for I cubed, so that's 5 squared times 5 plus 1 squared divided by 4, and then I pulled my constant in front of my sigma notation, and I multiplied it by the formula that we can use for I squared, which once I plug in the n term, it became 4 times 5 plus 1 times 2 times 5 plus 1 divided by 6. Simplified that, 25 times 3 divided by 4 plus 20 times 6 times 11 divided by 6. I factored out a 4 here, and I factored out a 6 here. So that became 25 times 9 plus 20 times 11. 25 times 9 is 225. 20 times 11 is 220. Add those together, the answer is 445. And our final problem, we have a starting point of I equals 1, that's where we're starting, and we have an ending or stopping point, or an upper limit of summation of 9. And we're dealing with I minus 1 squared. So the first thing I did is I FOILed it, so I get I squared minus 2i plus 1. And then I separated it, not dropping my sigma notations, carrying through my sigma notation. So I have I squared minus 2i plus 1. I used the formulas that we learned. So that is 9 times 9 plus 1 times 2 times 9 plus 1 divided by 6 minus 2 times 9 plus 1 divided by 2 plus 9. Simplified that. That's 90 times 19 divided by 6 minus 90 plus 9. And I factored out a 6, so that becomes 15 times 19 minus 81. And 15 times 19 is 285 minus 81, which is 204. I hope that this helps you better understand summation and calculus.